So now we have a joint density function of 3 variables, and from it we have to find joint density function of 2 variables. So first we have to find the joint marginal density of y and z. So that would be a function of y and z. So it's this one, y between 1 and 3, z between 0 and 3. And since the function has just y and z in it, that means we have to find it by eliminating x, and x is eliminated by integrating it out. So g, y, z would be obtained by integrating x out. So f of x, y, z, and we integrate it with respect to x, and x is going from 0 to 1 in this range. So normally this would be negative infinity to infinity. You would integrate the entire x out, but x is 0 to 1 in the non-zero range of the function. Dx, and y and z will be treated as constants. So the 4 y squared z by 3, that's a constant, and this is the only variable as far as x is concerned. So once you integrate it, you get x squared by 2 for that, and x goes from 0 to 1. Let's write it, x equals 0 to x equals 1, so that we know which variable we are substituting in. So 4 y squared z by 3, or we can even combine this 3 and this 2 into a 6. And then x squared be 1 squared minus 0 squared, and then this is just a 2/3. So we will get 2y squared z by 3, because this 1 squared minus 0 squared is just 1. So 2y squared z by 3. So let's put a fraction. 2y squared z. No. First you write a y and then this squared z by 3. And similarly, you would integrate the, okay, so now they're saying find the marginal density of y. So you already have g by z. So the marginal density of y will be a function of y by integrating the z out of this equation, and y goes from 0 to 1. So it's choice A. And therefore we will have h of y. So now we have this joint density of 2 variables. So we integrate basically g of yz and integrate the z out of it. So gyz is 2y squared z by 3, and z goes from 0 to 3 dz. So now with respect to z, the y is a constant, so 2y squared by 3 is a constant, and then this z is the only variable, so its integral is z squared by 2, and z goes from 0 to 3. This 2 can cancel out, so you have y squared by 3, and then put in the value for z, so 3 squared minus 0 squared. That's a 9, and then 9 divided by 3 is 3, so you get 3y squared. And then we need this weird kind of probability. So x is going over a range, y is going over a range, and z is going over a range. So for this one, we will use the original function. So probability x is between 1/2 and 3/4. Y is greater than 2/3. And z is between 1 and 2. So one thing we have to be careful about is make sure that these ranges are within these corresponding ranges. Otherwise, we have to adjust these because remember that outside these ranges, the function is 0. So 1/2 and 3/4, x is between 1/2 and 3/4, so that lies completely between 0 and 1. So this would be a triple integral because there are 3 variables running around. So 4xy squared z by 3, and let's say dx, dy, dz. So if you write them in this order, then the most inside variable is x, so the most inside integral would be the x integral. So x goes from 1/2 to 3/4. And then the next one is y. So y is bigger than 2/3. So now the only non-zero part of y is between 0 and 1. So bigger than 2/3 means going from 2/3 to 1. Normally bigger than 2/3 means 2/3 to infinity. But from 2/3 to 1, we have non-zero. And then after 1, we have 0. So practically 2/3 to infinity in this case means 2/3 to 1, because at 1, it's the end of the world for y. And then z goes from 1 to 2, which is within this 0 to 3 range. So 1 to 2. So first variable of integration is x. So with respect to that, the 4, so actually 4/3 is a universal constant, so that can be pulled out of the whole thing. 1 to 2, 2/3 to 1, and now we are doing the integration with respect to x first. So the y squared z is a constant. Remember, 4/3 has already been pulled out, so we're left with y squared z and the x. And the integral of x with respect to x is x squared by 2. So x goes from 1/2 to 3/4. Okay, and now this 2 can even cancel with this 2, with this 4, and we get a 2/3 outside. 1 to 2, 2/3 to 1, and we have a y square z, and then this x square. So when you substitute the limits, so it'd be 3/4 square minus 1/2 squared. Okay, so 3/4 is squared is 9 by 16 minus 1/4. So 9 by 16 minus 4 by 16 is 5 by 16. So this quantity is 5 by 16. So you have 2/3, and I can write that 5 by 16 outside because that's a constant. And then inside I have this. And I have dy dz left over after the x is gone. Okay, so 2 1 times, 2 8 times. So this is 5 by 24. Okay, so the next variable of integration is y. So leave the outside one, and the inside one is with respect to y. Z is a constant, and y integrates to y cubed by 3. Y squared integrates to y cubed by 3, and y goes from 2/3 to 1. Okay, so this 3 can even go outside here with the 24, so that gives us 5/72. And then z is here, 3 is gone, so then y cube would be 1 cube. 1 cube is 1, and 2/3 cube is 8/27. Okay, so this is 19 by 27, so you have 5 by 72, 19 by 27, and then it's just the integral of z left. So z integrates to z squared by 2, from 1 to 2. So that's equal to, so this already is 95 over, so let's see, 72 times 27 times 2, so 72 times 54, so that's 3888. And then this is a z, so this 2 is being taken care of, and the z squared would be 2 squared minus 1 squared. So that's 4 minus 1, that's a 3. So 95 over 3888 times 3. And 3 cancels with this, 3 1 times, and 3 2 times is 6, 28, 3 9 times 27, so 296. Okay, so we have 95 over 1296. Okay,